Until now, you've mostly used the wind and temperature information to determine wind corrections and fuel requirements, as well, of course, as meeting Aunt Grace on time. As an instrument pilot, the winds aloft are even more important to you. That's because you'll base alternate airport requirements and lost communications procedures on your estimated time of arrival. In fact, as you already know, there's a space on your flight plan form for just that very thing. No, it doesn't actually say estimated time of arrival, but you need to know how the winds aloft will affect your Skyhawk's performance in order to fill in the estimated time in route block on the flight plan. And to do that at your cruising altitude, you're going to want to know how fast the wind is blowing and from which direction, as well as the temperatures aloft, so you can calculate your ground speed. In fact, you may want to pick a cruising altitude based on the wind speed and direction, and hopefully enjoy a tailwind instead of a headwind. So as you might guess, the weather folks have designed a table to give you everything you always wanted to know about winds aloft, but were afraid to ask. It's called the Winds and Temperatures Aloft Forecast, or FD for short, and it's produced twice a day. So let's take a look at the Winds Aloft Forecast for Hill City, Kansas, HLC, and see how to read it. Now the table shows the station identifiers down the left, and HLC is the fourth one down. The altitudes for the winds are across the top. This first column shows winds at an altitude of 3,000 feet MSL, the next 6,000 feet MSL, and so on up to 39,000 feet. So if you want to know the winds and temperatures aloft at Hill City at 6,000 feet MSL, simply look at the fourth row down and the second column over. Now the first two digits, the 17 there, are the direction the wind is from to the nearest 10 degrees. Add a 0 to that to get the complete number of 170 degrees. This wind direction is relative to true north because that's how all winds for weather purposes are given. Winds aloft forecasts, area forecasts, surface weather observations will always provide winds relative to true north. Only the ATIS winds, the winds specifically for takeoff and landing, are given to you relative to magnetic north. The next two digits, the 07, are the wind speed in knots, 7 knots. And after the wind speed, you have a minus sign for the two-digit temperature, the 01, that follows, a temperature of minus 1 degree C. All temperatures aloft are given in degrees C. Now take a look at the winds and temperatures aloft at MKC at 3,000 feet. Here the wind direction is from 05, meaning 050 degrees, and the wind speed is 7 knots. But notice there's no temperature. Temperatures are not given for the 3,000 foot level or for levels within 2,500 feet of the station elevation. Now look at Denver, DEN, the third station down from the top. Notice that there are no winds forecast at either 3,000 feet or 6,000 feet MSL. That's because Denver has an elevation of 5,431 feet, and no winds aloft are forecast within 1,500 feet of the station elevation. But what are the winds and temperature aloft at Denver at 30,000 feet? Well, if we look across to the right, we'll find out. Now, as before, the first two digits, the 23, are the wind direction. The middle two digits, the 53, are the wind speed. And the last two digits, the 47, are the temperature. But what happened to the minus sign? Well, they don't bother to include the minus sign because temperatures will always be negative up at an altitude like 30,000 feet. And how would you know that? You'd look at the note just above the table where it says temperatures negative above 24,000 feet. Okay, back at Denver at 30,000 feet. What's your wind direction, speed, and temperature? Well, the wind direction is from 230 degrees, the wind velocity is 53 knots, and the temperature is minus 47 degrees C. You can put your own minus sign in. Now sometimes at high altitude you have winds of 100 knots or more, and that poses a bit of a problem because the FAA has only allowed 2 spaces for the wind speed. Maybe they're trying to save a few tax dollars in computer costs. To solve the problem, they play around with the way they encode the wind in order to tell you that it is 100 knots or more. They add a 50 to the first 2 digits representing the wind direction, then subtract 100 from the wind speed. Okay, uncross your eyes and quit saying ha. If you have a wind of 100 knots or greater in the table and you want to find out what it really is, you just work backwards. Take a look at St. Louis, STL, which is the bottom station, and let's take a look at the forecast for 34,000 feet. And the forecast for St. Louis for 34,000 feet gives the wind as 730649. So what's the wind direction and speed forecast to be? Well, normally you'd look at that and you'd say 73, that means 730 degrees. And just how would you get a wind direction like that? Well, obviously there is no such wind direction. That's your clue that the wind speed is stronger than it appears to be. It shows a 06, which looks like 6 knots. Logically, though, 6 knots wouldn't be very much wind for 34,000 feet, would it? It's actually 106 knots. So to decode it, you'd take the 730649 and break it apart into the different components. For wind direction, they give you a 73. Since there is no such wind direction as 73, what you do is subtract 50 from the 73, and that leaves you 23. The 23 represents a wind direction of 230 degrees true. Simple so far. Now, since you subtracted a 50 from the wind direction to get the correct direction, that tells you that you'll have to add 100 to the apparent wind speed to get the actual wind speed. So take the 06 that's shown, add 100 knots, and you get a wind speed of 106 knots. Temperature is easy. The 49 there stands for a minus 49 degrees C because you remembered to put your own minus sign in front of it. And the forecast wind is a wind from 230 degrees true at a velocity of 106 knots and a temperature of minus 49 degrees C. Now, what happens if the wind is more than 199 knots? Well, they just call it 199 and encode the velocity as before as 99. So let's say that you have a wind from 300 degrees at a velocity of 200 knots and a temperature at that altitude of minus 54 degrees C. It would look like this on the winds and temperature aloft forecast, 809954. To find the actual wind direction of 300 degrees, you'd take the 80 and subtract 50 from it to get 30, then add a 0 for 300 degrees. Then you'd add 100 to the apparent wind velocity of 99 for a wind velocity of 199 knots. And you'd put a minus sign in front of the 54 for a temperature of minus 54 degrees C. So if the wind is more than 199 knots, you won't know exactly what it is. But no matter what it is, it would be a heck of a headwind for your Skyhawk. Although you probably won't see wind speeds like that in your Skyhawk, from time to time you will see light and variable winds. In order to show that the winds are light and variable at a particular station, they enter a code of 9900. 9900 means that the winds either are or are forecast to be light and variable, and that means less than 5 knots. Now let's talk about standard temperature. As you know, in the International Standard Atmosphere, also called ISA or ISA, the temperature at sea level is plus 15 degrees C. and the temperature cools at the rate of 2 degrees C for each 1,000 feet of altitude above sea level. So let's say that you want to know how the forecast temperature at 9,000 feet MSL compares to the standard or ISA temperature. You simply start with a sea level standard temperature of plus 15 degrees C and subtract 2 degrees C for each 1,000 feet of altitude that you are above sea level. In this case, you're 9,000 feet above sea level, so 2 degrees C times 9 is 18 degrees C that you'll subtract. And this will give you a standard temperature at 9,000 feet MSL of minus 3 degrees C. Now, take a look at this winds aloft forecast and notice that the forecast temperature at 9,000 feet at this location is minus 10 degrees C. So, if the ISA or standard temperature is minus 3 degrees C and the forecast temperature is minus 10 degrees C, then the forecast temperature is 7 degrees C colder than standard, and you would express that as ISA minus 7 degrees C. And armed with all this information about wind speed, direction, and temperature, there's no excuse for you to be blowing in the wind aimlessly.